Greetings, fellow muckers. Today, we're going to be working over a first derivative test problem. The problem: f of x is equal to 3x to the fourth minus 4x to the third minus 6x squared plus 12x plus 1. In part A, we'll have to find the interval on which f is increasing and decreasing. And in part B, we're going to have to identify the local extrema of f. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now, let's work on it together. So in part A, we need to find the interval on which f is increasing and decreasing. So to do that, we're going to have to find our critical points for our function. To find our critical points, we need to set f prime of x, our first derivative, to 0. So if we do that, we get f prime of x equal to 12x to the third minus 12x squared minus 12x plus 12. Now we can simplify this by first removing our 12. So we get 12x cubed minus x squared minus x plus 1. And then we can simplify this down again. So we get 12x plus 1 x minus 1 squared. Now that we have simplified our derivative, what are our critical points? Our critical points will be x equal to 1 and x equal to negative 1. Now we found our critical points. Our range, our intervals will be from negative infinity to negative 1, negative 1 to 1, and 1 to infinity. So now let's figure out where does our f function change from negative to positive or positive to negative. So let's label this as negative 1, 1. So let's do behavior of f, and then let's do f prime above. So if we plug in negative 2 into our simplified derivative equation, what do we get? So we get negative 2 minus 1 plus negative, but this is positive, is squared. So negative 2 plus 1 is negative 1. So this whole thing is negative. So this is negative. Therefore, the behavior of f is decreasing. Decreasing. And now let's plug in a value of 0. What is our f prime? Is it positive or negative? We plug in 0 into our derivative. For f, we get negative 1 squared, which is positive. 0 positive, so we get positive. So this is increasing. And if we plug in 2 into our f prime of x, we get 2 minus 1 is 1, positive. 2 plus 1 is positive, so this is also positive, it's increasing. So this is the find the interval in which f is increasing and decreasing. So this is from negative infinity to negative 1. Our function is decreasing. From negative 1 to 1, our function is increasing. And from 1 to infinity, our function is increasing. That is the solution for part A. Now, identify the local extrema of f in part B. So, f is a polynomial. So it's continuous on negative infinity to infinity. So f prime, as we found, changes signs at negative 1, at x equal to negative 1. So if we follow the first derivative test, f has a local minimum value at f of negative 1. So we have a local minimum value at x equal to negative 1, and this is going to be f of negative 1 is going to be equal to negative 1 3 minus negative plus 7 1 minus 10. Yep, minus 10 at x equal to negative 1. And we see that at our other critical point, x equal to 1, both sides are positive. So there's no local extreme value at x equal to 1. But we do have a local minimum value at x equal to negative 1. And that is going to be the solution to this problem. I hope this video helped. If it did, please consider subscribing and liking this